Hello, this is Francis Kelsey School. I'm Mr. Abbott, and I'm doing a seminar for Pre-Calculus 12, Learning Guide 4 on logarithmic functions. Okay, logarithmic functions. For exponential functions, y equals c to the x, which we did in Learning Guide 3. Now, Learning Guide 4 is logs, and we are doing now the inverse of those exponential functions. So they can be written in this form: log c, which is the base of the log, to x, which we call the argument. So remember that when you're dealing with logs, you have some restrictions you have to remember. C, which is the base of the log, must be greater than 0, and it also cannot equal 1. Now, the other restriction is x, which is the argument, has to be greater than 0. In other words, it cannot be a negative. Now, since our numbering system is based in powers of 10, logs with base 10 are widely used and are called common logs. And we'll see it written like this: log 3. You don't see a base there, but what it really means is log base 10, 3. And you're probably asking, where do logs come from? Why do we use logs? Well, logs were done years ago in the 1600s and 1700s when mathematicians and scientists were multiplying or adding very, very large numbers, or dividing very large numbers, or very small. And they needed a way of doing it that wasn't very arduous, which means very long, taking a lot of work to do. So they invented logs, and it's used a lot in math, which we'll be using. All right, topic 1, understanding logs. So we are going to evaluate logs. So I'll get my pen here, and let's use purple. All right. Now, when we evaluate a log, I think of automatically the boot up rule. And I'll show you the boot up rule. It works for me and I like it. So remember this, that what we're really doing with logs is we're thinking like this: 5, which is the base, see there's the base, 5, to what power, so we don't know what the power is, must equal 25. Okay, that's what you're really thinking in your head for these easy ones. So, well, I can do it through Learning Guide 3, but I'm also going to show you the boot up as well. So let's do it through Learning Guide 3. So let's say 5 to the x equals, now I'm trying to think of 5 to what power equals 25, and we know it's 5 squared. So we know cross out, so the answer is 2. Okay, that was pretty straightforward. But we can also do it through boot up. Now I'll show you a boot up method. Okay, here we go. So I'll do this one right here. I'm going to make it equal an unknown we'll call x. So we're trying to solve it or evaluate it. Now there is a base here. You can't see it, so I'm going to write it in because I just showed you earlier. It's base 10. Okay, because log with nothing there in the base is automatically base 10. Now I'm going to boot up, which means I'm going to take this is my foot, this log, and boot up. See, it just kicks that guy up. So what happens, it goes 10 to the power of x, let's boot it up, equals this argument right here, that argument 10. Well, now we're back to the same step we did in Learning Guide 1, or pardon me, Learning Guide 3. So we know that's power 1. So the answer is 1. Okay? So let's go down to D, because D is a little bit different. We haven't C. Well, let's go back to C, sorry. C. So let's do boot up, equal sign. Let's put an X there. Let's boot up. Okay, there's my boot up. So that's 8 to the X equals the argument 1. Now some people have forgotten back to their grade 9 days. Now when we have an exponent that equals 1, there's only one answer. It's 0. So it's the one that's forgotten a lot, because 8 to the power of 0 we know is 1. Okay? Anything to the power of 0 is 1. So that's an easy one. Okay, now this one. When we have a radical, see that radical sign now, we need to change it to a exponent. So all I'm going to do right now is just do a little bit of rewriting, and then we can solve it. So it's log base 2, and back to our grade 10 days now. This is 8 to the half. Okay? Now, let's do our boot up. Okay, kick that 2, all the way up to kick that X up. So that's 2 to the power of X equals 8 to the power of 1/2. Okay, base change, so 2 to the X. Okay, now we know that 8 can be rewritten as 2 cubed, because it's the same thing as 8, 2 cubed. But we have that halfway in there, so we're timesing it by the half. Oops, long line there. So 3 times a half is 1.5. So we know the answer is 1.5. Or 3 over 2 if you want to write that. Okay, with this one, so let's rewrite log base 9. Now this guy is 81. Now there's an invisible 1 here. You can't see it. It's invisible. Remember, this goes to the numerator, and this index becomes the denominator. So it becomes 1/5. Okay. All right. Now we can make it equal X and just do our little boot up method. Okay. So that 9 boots that up. So now we have 9 to the X equals 81 to the 1/5. Okay, now I'm not going to go to base 3. I could go to base 3, but I know this number 81 is really 9 squared. I can see that. So I'm just going to leave it at base 9 now, because I have a 9 over here. All right. And now I have a 1/5 weighting, so don't forget about that 1/5, because it's still there. And now I have to take the 2 and multiply by 1/5, which gets me 2/5. So there's my answer, 2/5. Okay. Now this one, this 9 right here is out in front of the radical, which we call this a mixed radical. Now when we're dealing with logs, it's much easier to make the mixed radical into an entire radical and work. So that's easy. We just take the 9, we square it, and we times it by the 3. And we get, what's that answer? 81 times 3 equals 243. So now 243 is my entire radical. And now just put the log. And it's base 3. Okay. So let's make it equal x. And let's do the boot up. So that 3 kicks that up. So it's 3 to the x equals 243 to the 1/2. Okay. Now, we have to try and think of 243 to base 3. So now we're just going to throw some numbers in. Let's try 3 to the power of 6. Nope. Let's try 3 to the power of 5. And 3 to the power of 5 is it. So now we have 3 to the x equals 3 to the power of 5, because 3 to the power of 5 is 243, times that half that's waiting there. And our final answer is half of 5 is 2.5. Okay? All right, so let's go to the next page and let's try to evaluate some on your own. So I'll give you some time. I would suggest just to pause my video because I'm going to write the answers and you can work it out and then just check your answers with my answers. Six is the answer for the first one. -1 is the answer to B. And 3.5 is the answer to C. All right, well done. Let's move on.